I thought I'd go over the hardware as it stands at the moment. This is the main board, this is the keyboard side, and you can see there's quite a few wires on there because I got some of the signals wrong. It's just the same key matrix, nothing else on this side really. The other side though, we've got the Raspberry Pi Pico. We've got some latches here that do the keyboard scanning to give extra GPIOs and various other signals that are needed. The display here connects on a ribbon cable flat connector. There's a 12 volt DC converter here, which is for the OLED display that requires 12 volts to run. The real-time clock chips over here, and then there's some voltage regulators to supply all the circuitry. The connectors here, which unfortunately don't match up absolutely perfectly with the power supply board, I need to adjust that on the artwork. They provide the signals to operate this, which is the power PCB, as I call it. This has got the slots on it. There's a bit of plastic there, plastic moulding that fits over some of the circuitry. That's useful for getting the top slot hardware to plug in properly. There's the two slots here for data packs, and we've got level shifters here because these are 5 volt and the Pico is 3.3, so we need level shifters. And we've also got another shift register here which provides extra GPIOs for driving this board. We've got a power supply here and a circuit that switches it on and off for the Wi-Fi module that's here. Top slot connectors here, and these are the female version of the connectors that come in from the main board, the processor board. Here will be, when they turn up, still haven't turned up, will be some serial EEPROMs which I'm hoping to use to dump the RAM when you power off. So when you power off, it'll dump the RAM in those and then just completely switch itself off. It won't be on at all, and it means that you don't lose stuff when you pull the battery out. So what I've ordered are chips which are 64k bytes each, so there's two there, so that's 128k bytes. So you could use that for whatever you want really. 2 copies of the RAM. You could save one version of the RAM and then another version for some other setup. That would work for an LZ64. For the smaller versions you could have multiple copies in there. You could also store the emulator state as well, the processor state, so you could just switch off and then come back exactly where you left off. That would need more than the 64k, so you probably couldn't do that on an LZ 64 and have 2 copies. You'd have one for the configuration and one for the actual RAM of the unit. So there's options there, but I'm hoping to just save the RAM, bring it back, and then tell the emulator that it's a warm start and it will just start up again. But may be able to do extra things that the original organiser couldn't do, which would be things like turning on. Well, you create a snapshot of the whole thing, the emulator, the processor state, port states, everything, and then you can switch back on in the middle of whatever you were doing. Maybe that may not be possible, but it should be, because it's an emulator. Everything is stored in firmware. The display fits in at the moment. I've cut a little foam mounting for it, and it fits really nicely in there. It actually fits on the plastic, transparent plastic part. It latches itself in there. There's a little bit of movement that way, but this way is no movement at all. And then the ribbon cable just wraps around the top of the board like that, and you plug it in, the board fits in there, and you're off. This one then, where is it, power board, that then fits in there in the case. It's pretty nice. There's a bit of movement that way, no movement that way, but this is, I think, what the original did, but I mean it does fit in there. And then when they're together, I normally have that coming out the top, everything coming out the top slot hole, and I leave this bit of plastic out at the moment. That fits on there. Don't want to turn it over, all the keys will fall out, and that's out by 1 pin, but that fits on there, like that. So that becomes your unit, and that's where the hardware is at the moment. There's a lot of mods on both boards, so I don't think I'll be making another prototype out of these particular bits of artwork. I've got quite a few sets, but it is quite a lot of work to get it to this state of working, and I think another issue of board will be the best way to go. It'll save a lot of time. There's extra transistors on there and all sorts of things that need to be put onto the PCB. But yeah, it's working pretty well at the moment. More or less everything sort of major is working. There's been quite a few little problems. I mean, this is just that I need the transistor to switch on harder than it can turn on with a single transistor, so I've got to have two. That's just due to the voltages that are coming out of the Pico, and various other things. Similar sort of problem here, switching the 12 volts on. I was switching the ground, which I've done before on this circuit, but that didn't work very well, so the ground is now hardwired, and I'm actually switching the supply for that, which is just as good. It's not a problem. Various other bits and bobs and things that need changing. So at the moment it's configured using not jumpers, but these solder, well, they are jumpers, but they're solder blob jumpers, and I've used quite a few of those, so you can set it up to do different things, and that's quite a neat, quick way of configuring a PCB in a permanent fashion. I mean, using little jumpers would be just too large for the space available. One downside is that to change the jumpers you need a soldering iron, but there we go. So I've tested most things. The clock isn't running at the moment. I need to do that, and obviously I haven't got any chips here for the RAM. I need to wait for those, solder them on and try that out. These are I2C. This is a serial data link. The display is also I2C, and it's on the same bus as these chips, and the real-time clock is I2C, and that's on the same bus as well. I only had enough pins for one I2C bus. Hopefully that will be okay. It's okay at the moment with what we got on there. We got that on there and the display, and everything's fine, but well, hopefully it'll carry on being fine. A few mechanical issues. These pins here aren't lined up properly with the PCB. They're out by about half a pin, so I've had to bend these wire connectors to get them into the sockets, and I've got too many tracks around the screws here. That's why I either need a washer, which I could do, or I'll just lay it out and move the tracks away from the screws. That was just my mistake. Other than that, they fit in there pretty well, and I don't know what to do about the display, whether to carry on with the foam way of doing it, which is actually quite nice, or 3D print something to fit in there. Can I get that out again? I don't know how to go on that. I could 3D print something that's a bit more tailor-made, but the foam, it does actually work quite well. You need a bit on the back to hold the thing, to stop it from moving around too much, but yeah, I might try 3D printing something. Maybe it uses foam as well. You have to put a bit of foam there or something, but that's just details. And I haven't had any problems with it held in this way. It stays in place and doesn't move around, doesn't rattle or anything. But yeah, it's a bit DIY, and it's a bit difficult to reproduce. You have to actually sit down and cut one out. So 3D printed version would probably be better. But it's nice having the soft mount for it. But anyway, sort something out.